Okay, so yesterday we talked about this centroid theorem. Remember this thing? And we said that you start by finding the middle of each side, right? We're finding the midpoint of each side. How can we do that? Well, we can use our compass and we can put our stick point on our vertex and we can open it up just by looking whatever we think it is, slightly more than halfway. So then we draw our little half moons and then we switch it and put our stick point on the other vertex and draw our other half moon. And we don't change our compass setting for the side. Then we do it for this side and then we do it for that side. So if you don't have a compass, which you're supposed to have a compass, but if for some reason you don't have one, or if it's at school, we did this with circumcenter and you drew these with circumcenter. So it's the same thing. We're just finding that midpoint of the line. Or if you have a ruler, you can measure the line. So let's say this is like 6, then I would divide it by 2 because we're looking for the midpoint. So that would be 3, right? So then I measure out to 3 and I would put a little mark. So that's how you can find the midpoint of each side. So once you found the midpoint, then you take your straight edge and you go from the midpoint to the opposite vertex and you draw a line. And you do that for each side, midpoint to opposite vertex, midpoint, draw a line to opposite vertex. And once you've done that, you've done a couple of things. The first thing you've done is create congruent segments because you have found the midpoint of each line, and midpoint means you divided it in 2. It's bisected. Each side is the same. Each side is the same. Each side is the same. The second thing you've done is create the centroid. So that's where they all intersect right in the middle. That's at point P. And if you look at the centroid, the thing that makes this unique is that one side is going to be 2/3 in length and one side is going to be 1/3 in length. There's Kirsten. So we have 2/3 and we have 1/3 of our total length. Okay, so let's put a pause on this for 1 second. Kirsten.
Yes.
Okay, so thanks for signing in. I've got your attendance. What I would like you to do is go ahead and sign off and finish 7.2.
Okay.
I would like you to watch the videos of 7.3. It is the exact same thing as 7.2, but it's the converse theorems. It's the same thing.
Okay. I actually started working on 7.3. I only have questions on 7.2 homework from 14 to 16. I finished everything except the one that I have to like find the angle measure of like LMN. Can I log back on when y'all are done and you help me with that?
So let's have you log back on at 2:10. Is that okay?
Yes, that's good. Thank you.
Okay, cool. Thanks. Bye.
Bye.
All right, so moving back onto centroid, if we look at this example down here, let's look at S to W. We know this whole thing is 1 unit. Our S to Q makes up 2/3 and our Q to W makes up 1/3. And we know that centroid is a 2/3, 1/3 relationship. So we can tell by looking which part is the 2/3 and which part is the 1/3 just by saying which side is bigger. So out of SW here, we can say that SQ is definitely bigger than QW. We can tell by looking. So we know this 8 is the 2/3 and the QW is 1/3. Yes? Everybody still with me? Review from yesterday? Okay. So we can solve that by saying that SQ, which is 8 equals 2/3 of the whole thing. All right. I'm going to do it on paper here for you. 8 equals 2/3 of our whole thing. Our whole thing was SW, right? If you don't like writing 2 letters here, you could just use X for this. Now, we're trying to get this by itself. This is our whole side length. All right. So we need to get this whole thing by itself. So we need to get rid of this 2/3. So you can multiply by the reciprocal. Remember, if you're trying to divide by a fraction, you flip and multiply. So we're doing the same thing because typically what we would do is divide by 2/3 to get rid of it. And when dividing by a fraction, you flip and multiply. So this cancels out. And now to multiply a fraction by a whole number, put your whole number over 1 and multiply straight across. So we have 24 over 2 equals our whole side length. 24 over 2 equals our whole side length.
Her.
Yes?
Ashley wants me to tell you that she can't get into the meet.
Oh, okay. I'm recording it for her.
Okay.
All right. So now we have 12 equals SW. All right. So keep that in mind. 12 equals SW. So our whole side length here is 12. Our 2/3 side is 8. So what's left for our 1/3 side? 4. 12 minus 8 is 4. So that means that this 1/3 side is 4. The whole thing is 12. This part is 8. This part is 4. Another way to do that is to solve it visually. We have this line, right, which is SW. And we know it's divided into a 2/3 side and a 1/3 side, right? And we're dealing with thirds. So we can go ahead and divide this thirds into half. So now we have 3 parts, okay? This part here we know to be 8. We don't know what this part is. If 8 makes up 2/3, each part of this would be 4, right? So then we can say, oh, this part must also be 4. So our whole thing must be 12. Our missing part here is 4. That's a different way to solve. Okay, let's move on. All right, and then we did the monitoring progress yesterday. We did this, and we put one in the coordinate plane here. Do we need to go over coordinate plane? Speak up, we need to go over it, yes?
Yes.
Okay, let's go over that. Okay, so if we have one in the coordinate plane, they've given us this blue triangle. First, we have to find centroid, okay? So we're gonna pick a side and we're gonna find the midpoint of our side. How do we find the midpoint of a line in the coordinate plane? We use midpoint formula. Yes, correct. So step 1, midpoint formula. So we're gonna take x1, here's 2, plus x2 divided by 2. There it is. Now we're gonna take y1 plus y2, right here, divided by 2. So our midpoint coordinates for RT, for this line, are gonna be 5, 2. So we're gonna go ahead and mark that on here. We're gonna plot it, 5, 2. Now we're going to draw from our midpoint to our opposite vertex. So we're gonna draw straight up here. Now, on this particular example, let me turn the light off and see if that can fix the glare. Hold on. Or at least darken it. That's better, huh? Yeah, less glare. Oh, it's still glary. Hold on.
It's not as, yeah, that's good.
Better? Okay. All right, so on this particular example, when we found this midpoint and we drew to the opposite vertex, we ended up with a vertical line. And you can tell because it goes straight up the grid line. So at this point, you have 2 options. Option 1, find the midpoint of your 2 remaining sides and draw from your midpoint to your opposite vertex. Then where they intersect is your centroid. Or 2, since it's a vertical line, you can actually use a formula to find your centroid and you don't have to do any more work. Some people don't like multiplying fractions. So if that's not you, find your centroid of your other 2 sides and draw it. Either way, you're still going to end up with the answer. So since we have this vertical line, we can say, okay, what is the distance of our vertical line? All right, so look at your y values because it's vertical. So because our x values are the same, so that's not going to help you. So here we have 8 and here we have 2. So our distance is going to be 8 minus 2, our absolute value of 8 minus 2, which is going to be 6. So our distance here is 6, okay? So we're going to take 6 and we're going to multiply it by 2/3 to find our 2/3 side. So this is what we're doing right here. So we've multiplied it 2/3 by 6, which is 4 units. So we're going to start here and we're going to move 4 units down, and that's where our centroid's going to be. Okay.
Miss Herrera,
Yes?
I was checking RenWeb and I saw that it said that I was missing 6.2, but I remember putting that in your tray.
I will check.
Yeah, me too.
Those are your, hold on. Okay, let me look. I do believe I only had not very many, like 4 of them. Oh my gosh, can you
Mine should be in there.
I can't look in the tray right now because I'm at home. However, okay, 6.2, are you missing, Ben? Oh, you're missing both of them. Okay, so 6.2 had a practice A that we did in class, and it had problems 21 through 24. I graded everything that was in there. I only had Pages, who she emailed them to me, and I had Joseph, Ashlyn, Jackson, and Nate. That was all I had.
For the graphed one.
The 4 problems that you did on your paper. So it was practice A, and it was 21
I
through
think mine
24
is.
from page 316. So those are the only ones that I had in the tray when I graded them.
Do you want me to turn this into Google Classroom?
Yes.
Okay.
So wait, turn what into Google Classroom?
The graph stuff.
If you have it.
Okay.
So I graded the ones in my tray. So if you happen to turn it in, yesterday, then I wouldn't have graded that because it was from last week.
Okay.
But if you have them with you, then you can, let me see if there's a place to submit them. Hold on. Because I haven't handed those back yet. Yes. Well, hold on. Not everybody has oh no, there should be a place. 12. Yeah, there should be a place to turn in the graphed homework. So let's see. Joe, I see yours here. Hey, Luke, you know what? Yours did not work. When you turned in that 21 through 24 graphed homework, it sent a link instead of a picture. And so I can't grade it because it's just a link to your Gmail.
All right, I'll send it again.
Perfect. Thank you. And then let me just make sure. Yeah. Yeah, there's a place for if I didn't call your name that I already have yours graded, then there's a place for you to turn it in there. Nate, can you email me your work from when you were absent? Those 2 worksheets I gave you. And then I am looking at everyone else's. And then Joe, I got some emails from you today, and so I will look at those. I'll grade all that stuff tomorrow. So it'll be all updated for progress reports. Okay, so let's move on here. Okay. So today, okay, so are we better with Centroid? Are we okay?
Yeah.
Yeah,
Yeah,
I'm good.
we can try to do that assignment now. Okay. All right, so today we're going to finish the section and we're going to do altitudes. I'm not going to ask you to do a lot of altitude problems. What I am going to ask are questions to make sure you understand the concepts of altitudes, okay? So if you look at this right here, page 321, if you happen to have your book. If not, just follow along with me. That's why I have the book pulled up on this online for you here. Okay, the altitude of a triangle. Think back to when you learned how to solve area of a triangle, okay? What did you do? You say area of a triangle is 1/2 base times height, right? So here's our base and here's our height. Yes? The altitude is just your height of a triangle. That's all it is. It's a fancy name for saying the height of your triangle. So what do we know about the height of our triangle? Well, it's perpendicular to our base, right? So our altitude forms a right angle to our base, which is what it does when we try to find the area of the triangle. 1/2 base times height. How do you know it's the height? Because it forms a right angle with the base. This is the height of the triangle, okay? So the orthocenter is just where all the altitudes cross. So if I was to take this triangle and start here at point A and draw my height, draw my altitude straight down and have it be a right angle, I would get this point right here, F. Then if I were to turn it, okay, I'm going to turn it, and now I'm going to do it for this other side. Okay, I'm going to do it right here for this side. I'm going to come to my opposite vertex, which is B, and I'm going to draw it straight down to where it forms a right angle. This is my altitude from point B. And then if I was to turn it the other way, I think you guys get the idea. But now I'm finding the altitude, wrong way. Oh my gosh, there we go. Sorry, it's like backwards in the camera. Now I'm going to come over here to C, and I'm going to draw my altitude down, straight down to this line, and I'm going to find my altitude here. Where all the altitudes meet is the orthocenter, okay? That's it. That's all it is.
That looks exactly like what we did yesterday.
Kind of, except yesterday we found the midpoints of each side and we drew it to the opposite vertex. So it was coming from like here, from your midpoint. There were no right angles involved,
Yeah,
but is similar.
How do
That
we know we're supposed to start drawing the line?
That is a great question. So that's what we're going to do now.
Yeah.
Okay, so some important things to note. Put this in your notes, please. Is just like circumcenter, we can classify our altitudes on the triangle. So if you have an acute triangle, your altitude is inside the triangle. That's the same thing as circumcenter, the first one we did. Remember, if we had an acute triangle, our circumcenter was in the triangle. If we have a right triangle, it's on the triangle. Now it's different where it is, because here on the right triangle, our altitude is right here at the vertex where our 90-degree angle is for our right triangle. Whereas with circumcenter, it was up here. So both on the triangle for right triangles, just on different points. If we have an obtuse triangle, it's outside the triangle. So now you're going to go the opposite way. You're going to go above your obtuse angle. So when we did circumcenter, we found our obtuse angle here, and we knew that our circumcenter was going to be on the same side as our largest side, right? So we said, okay, where's our largest side on our obtuse triangle? Our circumcenter is going to be way out here. So it's opposite with altitude. So it's going to be on the other side from your longest side. So find your obtuse angle, and that's where it's going to be. Okay. So let's move on. Finding the orthocenter of a triangle. All right. The easiest way to find the orthocenter for a triangle is if it is in the coordinate plane. All right. So if we have this blue triangle and it says, they've given us our coordinates, here they are, and it says find the altitude of this triangle. Step 1. Do you have a horizontal line for one of your sides of your triangle? If you do, this is going to be much easier to find because you're going to be able to go to your opposite vertex and draw straight down and create an altitude. Just like you would if you were given this triangle in the coordinate plane and they said find the area, you would say, okay, what's my base length? Okay, what's my height length? And you would know to come straight down because that's how you find it. So same thing. If you have a triangle that has one horizontal side or one vertical side, you can find your altitude very easily. You don't even have to do any math. You can just draw it straight down. Okay, so we know this is one altitude here. And it's at here, it's at x equals -2. Okay, so how do we find another one? Well, figure out which side you want to use. So pick one of the other sides. It doesn't matter which one, pick one. Okay, the easiest one I always tell people to look for is find one that has a slope of 1 or -1. And you can tell by looking, it goes right through the middle of every grid line here. So this one is going to have a slope of -1 because negative slopes go this way, right? Positive slopes go this way, yes? So this has a slope of -1. So we're going to start at our opposite vertex and we're going to draw a slope of +1 because we know that negative reciprocal slopes create perpendicular intersections, right? So we're going to start here because our altitude has to come from the vertex and we're going to draw a line with a 1, 1 slope, up 1 over 1, up 1 over 1 until we get to an intersection point. So you would draw your line here like this. And these would be your two altitudes that you drew. And where they intersect is your orthocenter. Now you can do the math to solve the slope. If you can't tell by looking that this is a -1 slope, you can do the math. You can take your x and y coordinates and do change in y over change in x to get this. And you'll need to for some of them. And solve for your b. Where does it intersect? At +4, so you know it's going to intersect at +4 right here. You can do all of that, but for most of these, you're going to be able to solve your slope by counting, and if you can remember to come to your opposite vertex from the line that you solved your slope for and count your slope and draw your negative reciprocal slope that way, you'll be able to find altitude very easily. Okay, so what we're going to do is we're going to try one. All right, so we have coordinates. We're going to do number 6 right here. Okay, we have A is 0, 3. B is 0, -2. Please try this with me. 6, or C is 6, -3. Okay, so the very first thing we're going to do is graph this. All right, so we have A, 0, +3, 2, 3. So here we go. A is 0, 3, right here. B is going to be 0. Oh, nobody caught my mistake. Come on, I get bonus points for making mistakes. If someone catches them, 0, 3, 1, 2, 3. Okay, A is 0, 3. B is 0, -2. So here's B. And C is 6, 3. 1, 2, 3, 4, 5, 6, -3. 3. Okay. Here's C. All right, let's draw a triangle. We have a vertical line. I'm on the crack. I got to move that a little bit. Okay. Well, okay, that was terrible. Okay, so what do we notice about this triangle? What kind of triangle is it?
It's obtuse
It's obtuse. So where is our altitude going to be?
on the outside.
It's going to be on the outside. Find your obtuse angle. That's the side it's going to be on. It's going to be over here somewhere. If we were looking for circumcenter, it would be across from our longest side. It would be over here somewhere because they're both outside. Obtuse equals outside for circumcenter and altitude. Both start with O. That's how you can remember it. Obtuse, outside. All right, so it's going to be over here. So we need to find our altitudes. And it's going to be outside. All right, so let's start with, which side should I start with? What's your path of least resistance? I want to know who knows.
Start with the AC side.
Okay, start with the AC side. So we need the slope of this.
It's whatever you called it. It's 1/1.
It's 1/1. And you know that because?
It's going through each of the lines on my graph.
Okay, it's going through each line on the graph. Over 1, up 1, over 1, up 1. Okay, so we're going to start with AC. That means we're going to come over here to B. So this was a -1 slope. We're going to come over here to B, and we're going to draw a +1 slope, right? Because we need a negative reciprocal line. So we're going to come up 1, over 1, up 1, over 1. And we're going to draw like this, right? Yes?
Yeah.
Okay. Yours hopefully looks better than mine. I have some graph paper up at the school that I will get because this is really hard to do correctly, not on graph paper. So I promise I will have graph paper next time to make it better because these should intersect not right like that. Okay, so what should I do next?
Now you do it on another side.
How about AB? It's vertical, right?
Yeah.
Okay, so if I have a vertical line, what is my perpendicular intersection going to be? A horizontal line, right?
Yes.
Okay, so what's my opposite vertex of AB?
BC.
But the point. What point is opposite of AB?
BA.
C.
Oh, C.
Because here's my line, so I'm going to find my opposite vertex, which is C. Now I'm going to draw it straight across. Okay? My horizontal line. So where they intersect, there's my orthocenter right there. I did 2 of them. I don't really need to do the third one. It would be from A. I can do the third one. I would find the slope of this side, and then I would come up here to A, and I would draw it, and it would intersect right here. Okay, so this here is my orthocenter. So it should be, I'm a little off because I'm off. Look at my lovely line here. But it should be, if you did it on graph paper, it should be -1, -3.
Yeah, that's what I got.
Okay, yes, good. See, it's really not that hard. If you do it in the coordinate plane and you just think logically and count your slopes, easy peasy. Okay. So let's do one more. Let's go with number 7. So we have, I just want to make sure we have a decent handle on it. Let's go with 7 is J, -3, -4, and K is -3, +4. And L is 5, 4. Okay. There we go. Let's see if I can move this so I'm not drawing in there. There we go. Okay. So here we go. Graphing this. All right, -3, -4. There's J, and K is going to be -3, +4. 1, 2, 3, 4. And L is going to be 5, 4. All right, what kind of triangle do we have here?
A right triangle.
Right triangle. So where is our orthocenter going to be?
On the inside.
Nope.
Oh no, it's gonna be on the triangle.
Going to be on the triangle. Okay. And we don't even have to do any work because where on the triangle is our orthocenter always when it's a right triangle?
On the 90-degree angle.
Always going to be on the 90-degree angle. So that right there is going to be your orthocenter. So your coordinates would be -3, 4. Not terrible.
Yeah, it's not bad.
It's not bad. Okay. So let's look at, yes,
I turned in the big ideas math assignment.
perfect. Perfect. I will look again and update those immediately when we're finished here.
Okay.
So let's look at, this is a proof. We don't need to do that. Let's look at this. On page 323 in your book is this great chart. Now, if you don't have your book, you can find it on the online book, okay? And it tells you all 4 types that we have learned to draw: circumcenter, incenter, centroid, orthocenter, okay? And it basically tells you what to do. So for here on circumcenter, we're drawing perpendicular bisectors of each side. Find your midpoint, draw a 90-degree angle. You do that with each one, a 90-degree line, okay? Then it tells us that the circumcenter P is of a triangle is equal distance from the vertices. So we know that here P, it's equal distance from the vertices. If we were to draw our circle on this one, it would go big around the outside of the triangle. Why? Because we're putting our pencil on the vertex and the stick point in the middle. So that circle is going to go on the outside. It's going to touch each vertex of the triangle. For our next one, in center, we're finding angle bisectors. Okay, and we practice drawing angle bisectors by using our protractor to draw correct angles of a triangle. Okay, that's where we had that assignment in the book where you had to draw a triangle with like one angle 90 degrees, one angle 50 degrees, one angle 40 degrees. Then I had you split it in half. I'm not sure if we're going to go back and add the compass to this one or not. I really just wanted you to learn how to draw the triangle with the protractor. Okay, so we bisected the angles. If you did learn, some of you did learn how to bisect angles with the compass, and that is totally fine. As long as you can still use the protractor to draw the triangle, then that's what I needed you to learn from this one here. The incenter is the point that is equal distance from the sides, okay? So you draw 90-degree lines to those sides, and your circle then sits inside the triangle. In center, circles inside. All right, the centroid is the one we did yesterday. That was the easiest one to draw because all you do is find the midpoint of each side and you draw to the opposite vertex, okay? Yes?
Yes.
Easy peasy. And this is our 2/3, 1/3. So there's a little bit of math with this one, but it's definitely the easiest one to draw. Okay, and then our orthocenter, the one we did today, you're just finding the altitude. You're finding the height of each side. That is it. Easiest to do in the coordinate plane, a little harder not in the coordinate plane. We're going to learn how to draw them not in the coordinate plane, but we're not going to do that online. I'm going to wait till we're in class. So please, please, next week when you come on, I don't know what day I'm going to see you next week because I don't know what they're going to make the schedule look like. Whatever days I see you next week, please make sure you have your compass and protractor. So, so important. And we have a big project for this chapter that requires a compass and a protractor, and it's all drawing. But it's kind of a fun project. So, and it's not difficult, but you do have to have your tools. And I do want to help you with it in class next week, but I can't help you if you don't have your tools. Okay. All right. So